That old iPhone in your drawer contains 40 times more gold per ton than the richest gold mine on Earth. Yet we keep mining mountains in Peru while phones pile up in closets. The reason we choose destruction over recovery isn't technical, it's economic, and it's getting worse. A smartphone contains over 60 different elements from the periodic table. Gold in the circuit boards, silver in the switches, palladium in the connectors, cobalt and lithium in the battery. Each phone is a miniature mine condensed into your palm. Here's the concentration that matters. Gold ore from a profitable mine averages 5 grams per ton of rock. A ton of smartphones contains 350 grams of gold. That's 70 times more concentrated. Silver, 70 times. Copper, 100 times. Urban mining should dominate geological mining by pure economics. Globally, we discard 50 million tons of electronic waste annually. Phones represent roughly 10%, 5 million tons of concentrated metal. The gold alone worth approximately $10 billion, just sitting in drawers, landfills, and e-waste piles. We're throwing away entire economies of recoverable wealth. Yet mining companies still blast mountains, process millions of tons of ore, and destroy landscapes to extract fresh gold. The permanent problem: if recycling phones is more concentrated, why do we mine? The answer isn't that we can't recycle. It's that economics makes it cheaper to destroy than recover. Here's what recycling a phone actually requires. First, collect millions of scattered devices from individual consumers globally. Transport them to a facility. Separate plastics, metals, glass, batteries. The phone manufacturers designed this to be impossible at scale. Then comes chemistry. Gold sits in microscopic layers bonded to circuit boards with epoxy and solder. Rare earths are alloyed with other metals in magnets. Lithium is embedded in battery chemistry. Separating these requires aggressive chemical processes. Each extraction step costs energy and generates toxic byproducts. Now add the economics. Mining fresh or benefits from century-old infrastructure and economies of scale. Mines operate continuously at massive throughput. Recycling phones requires building entirely new infrastructure. The upfront capital investment? Billions. The profit margin? Razor thin. Geology wins on cost, even when recycling should. And manufacturers profit from this dysfunction. Planned obsolescence ensures phones break or become obsolete every 2 to 3 years. Non-removable batteries, glued components, proprietary screws. The system isn't broken, it's built to block recycling. For decades, wealthy nations recycled e-waste by shipping it to developing countries. The United States, Europe, Japan. Containers labeled charitable donations or secondhand goods arrived in Ghana, Nigeria, India, China. What actually came? Broken phones, obsolete computers, worthless electronics. Recycling became an export problem disguised as charity. In Agbogbloshie, Ghana, one of the world's largest e-waste dumps, workers burn phone circuit boards over open flames to melt away plastic and reach the metal underneath. No protective equipment. Toxic smoke, dioxins, furans, heavy metals, saturates the air and groundwater. The gold you didn't recycle is poisoning communities you'll never see. Then China changed everything. In 2018, the country implemented its national sword policy, refusing contaminated recyclables and e-waste imports. E-waste piled up domestically. Recycling facilities couldn't process the volume. Phones went to landfills. A system built on poor countries taking rich nations' waste collapsed overnight. And what happened to the precious metals? They stayed in landfills. Mining companies didn't reduce extraction. We just started accumulating waste domestically instead of exporting it. Shutting the export valve didn't build recycling, it built bigger landfills. Current projections show e-waste reaching 75 million tons annually by 2030. Smartphones alone will account for 10 million tons. That's 7,000 tons of gold, more than the annual output of most gold-producing nations. Sitting in landfills instead of circulation. We're burying more wealth than we mine, and the gap is widening. Then there's the resource scarcity dimension. Rare earth elements, critical for phones, electric vehicles, wind turbines, are geologically scarce and geopolitically concentrated. China controls 90% of global refining capacity. Demand is exploding. Supply is constrained. Prices are rising. Yet we landfill the rare earths already refined, while starting new mining projects. and environmental costs multiply. Gold mining generates 20 tons of waste rock per ounce of gold extracted. Cyanide leaching, mercury contamination, habitat destruction. E-waste in landfills leaches heavy metals into groundwater, destroying mountains to mine and contaminating land with what we discard. The geopolitical implications worsen. Nations dependent on China for rare earths face strategic vulnerability. Trade restrictions, supply disruptions, price manipulation, all possible. Recycling domestic e-waste could provide resource independence, but mining remains cheaper. National security takes a back seat to quarterly mining company profits. Here's where physics favors recycling. Extracting gold from a phone is technically easier than from ore. The concentration is 70 times higher. The chemical processes are known. The environmental impact per gram recovered is lower. The technology already exists. The barrier isn't science. It's economic structure and policy failure. Several leverage points could shift this. Extended producer responsibility laws forcing manufacturers to fund take-back and recycling programs. Standardized designs making disassembly economical. Right to repair mandating replaceable components. Europe is testing. The US is debating. Speed decides whether we build or keep mining. Some companies prove it's possible. Fairphone designs modular smartphones where every component is user-replaceable and recyclable. Apple's Daisy robot disassembles iPhones for material recovery. These exist, they work, but they represent less than 1% of the market. Proof of concept doesn't scale without consumer demand shifts. The permanent constraint remains economic. Urban mining costs more than geological mining today. Changing this requires massive upfront investment. Governments must subsidize recycling or tax virgin extraction until the math changes. Physics allows a circular economy. Economics prevents it.